real quick, because we don't have all that much time, what I want to do is talk a little bit about our philosophy at Wärtsilä, and that overlays the overall approach to how we talk to owners about how can we comply in 2030, 2050. The conversation now obviously is all 2020, but that is going to pass, and then the conversation becomes how do I order ships that are getting on the way to compliance in 2030, 2050. So I have a few things I'm going to show you quickly, and if there's questions that come up, we'll have time for that. But the one I'm going to focus the most on is port and vessel optimization, because that's really a data way to solve the problem, not necessarily an equipment or a install-based way to solve the problem. And so when we look at the industry, what we've done as Wärtsilä is try to say, how do we connect the dots? How do we put the pieces together to get much higher efficiency? And so what's going on right now is this convergence where you have new technologies that are coming together in a way that enable us to have new business models and look at how we do business in a whole new way. And so you say, why should I change business and do things differently? Well, technology is maturing, particularly in sensor and satellite technology, so it enables us to do things that we could never do in the past. And so we call it ecosystem thinking. We're trying to look at the entire ecosystem, not any longer just as an engine manufacturer, propulsion manufacturer, but all the technologies that are available. How can we help owners get into compliance? And there's pretty much three ways we look at it, which is the efficient use of our resources, lower fuel burn, less emissions, more profitability, which is also a lower climate impact, and then also always looking at the safety of our people. And so why do we do this? When you start looking at the inefficiency numbers in the industry, they're horrendous. I mean, it's an incredibly inefficient industry, and we haven't squeezed any of that out, like, for example, the trucking and rail and airline industry has done much more aggressive in those areas of squeezing out inefficiencies. And so this was a study we did with McKinsey on just the container side of the house as an illustration of the kind of inefficiencies you have in the life of a vessel. Just incredible amounts of unused asset time, wait times, where the asset is not generating revenue and is not functional. So how do we look at that? Well, one of the biggest ways is new competencies via acquisitions. We're looking at acquiring data companies and data analytics, and so how does that apply to the owner? Well, one of the things we did is we took a ship with no mechanical changes at all, simply up the level of data and automation and integration on the vessel, and began to do what we call smart ports, or a project on just-in-time arrival system, analyzing all the pieces of the ecosystem of voyage of a vessel, not merely engine efficiency or propulsion efficiency, but from the time that vessel's in one port all the way to the other, all the functionality, the bunkering, the tugs, the pilots, the port facilities. How can we put that all together? And so we did this under big data analytics in a way that let us look at this vessel and say, how can we improve the performance of the vessel with no additional capital expense on equipment? Not a new vessel, same equipment, with just big data analytics. And so this is what we were trying to address, was this huge amount of wasted fuel and time in vessel operations. And so when we looked at this, the example was a 5,900 TEU container vessel, and all we did was apply big data analytics to an existing vessel. That's it. And what we found was we achieved about 10 to 12% improvement in the vessel's operation, its fuel burn, without any disruption to operation, without any new equipment. And so when you start thinking about 2030, 2050 compliance, I'm offering you 12% right here. Now, of course, and there's many solutions out there. It's not unique to Wärtsilä, but this just goes to show you how data can get you a big way to a 50% reduction in emissions if you're looking at 10 to 12 just by data analytics. I have a couple of videos. Just for the sake of time, I'm going to cut one of them out. And so other things we've done is when we start looking at this 12% savings, these add up to huge numbers for operators and cargo owners through the course of a year. These are big, big numbers. Hybrid tugs, another solution. And I'm using the tugs merely as an example. We talked a little bit about hybrid in the prior panel, just to illustrate the kind of numbers that you're looking at when you do a hybrid. Tugs are a great illustration of the concept. And when you start taking a look, tugs are an interesting example because they have to be built around a very, very high peak load that operates a very short period of time. Now, you can think about various places in shuttle tanker operations and other places that you might have similar circumstances. And when you start to look at the reductions in emissions from hybrid, it's really, really dramatic because you've shaved off that engine size and that inefficiency using a battery and a hybrid system. And again, I don't want to spend too much time on these, but just to illustrate the amount of reduced cost, which is reduced emissions, it's reduced fuel burn that you get out of a hybrid installation in this particular example. Very aggressive OpEx numbers. And if you go with LNG on top of that, we talked a little bit about LNG, LPG in the last panel, huge reductions in emissions. So you're killing multiple birds with one stone by the applications of these new technologies. Other things we're looking at Wärtsilä, new concepts in a machinery arrangement. Standard arrangement on most of the vessels we deal with, 2 strokes, fixed pitch propeller. But can we think about it differently? As opposed to the big engines, a couple of smaller, highly efficient engines that generate all your electrical capacity. You pull it out of gensets on a vessel, which is relatively inefficient, and you drive it into the main engine to get higher efficiency out of the vessel. And so what we do is we look at the entire life cycle of a vessel, everywhere it goes, and we start squeezing out, using various mechanical setups, additional efficiency for the vessel. So you start to see the pancake effect, where you're doing high data analytics, hybrid LNG, new engine setups for better power production. They may not be applicable in every situation, but as we pancake them, we begin to get closer and closer to that 50% reduction, and in fact exceed it. And this is one case that we've been working with Arista on this very setup. You heard from them in the last panel of how we move production into a much more efficient engine so that the overall fuel burn of the vessel comes way down. New methods in improving propulsion efficiency. These are driven by very complex computer fluid dynamics programs where we redesign the entire aft end of what would be a traditional vessel to get much higher efficiency out of the propulsion system. This system here, you'll typically see about a 6.5% improvement in performance over the identical vessel without this system. I don't want to go into too much of it, but it basically smooths out the wave flows that you have on a propeller and gives you much higher efficiency and much lower noise signature if you're worried about your noise signature going into ports that are now paying attention to that. Again, killing multiple birds with one stone, less fuel and lower noise. Another technology that we're deploying with TK right now is a VOC recovery system. Essentially what we do is we capture the off-gassing from a tanker that happens naturally and goes into the atmosphere, and then either A, if it's an LNG vessel, we burn it, so it's free fuel in essence, or we recondense it and inject it back into the tank, and those light fuels are then delivered to the refinery ashore. Either way, you're not letting that go out into the atmosphere, and you're reducing your fuel bill along the way. So how does that all come together, real briefly? So we just now, I think the first one's on the water, the next one's coming out soon. This is a series of shuttle tankers for TK where we applied all of these technologies across the board. These are a relatively sophisticated Aframax shuttle tanker, so the specification was somewhat high. I don't want to compare it apples to a standard Aframax tanker, but you'll get a sense here where when you apply all these pancake technologies of LNG, of hybrid, of the advanced generating system, the main engine generating system I showed you, of what kind of reductions you can get. And this would be their standard. This would be essentially the 2008 standard. This is about 2006-07, but approximately the 2008 standard they would be judged against for 2050. And then if you look at the numbers now that they're already going to have, they're 68% below their 2006, 2007 baseline. So essentially TK is achieving right now today, it's on the water in Korea, the first vessel, the 2050 standard, using a pancaked approach to various technologies. So if the question is, can we do it? We can. I don't want to give you any illusions that this is inexpensive. There's a lot of cost to a lot of these things that you may not have ROI on right away, but as they get deployed more and more in specialty situations, like shuttle tankers, you'll see the cost and the complexity come down like we do with any new technology to where they're more applicable to the commodity tanker market and commodity dry bulk market. And this is what you're seeing, this 68% reduction. So I'm going to run just a tad bit over, but I do want to show you this video. This is a little bit of our philosophy and how we look at the future and how and why we get up every day at Wärtsilä.
The future's not what it used to be. city was a place you could be sure of getting work. People flocked here by the millions. The promise of a better life. Fast forward to your parents' time, building a home and raising a family. And as you grew, so did the city. With waves of change, our lifestyles evolved. The things that excited us, the way we consumed, faster and faster. But the city wasn't built to grow like this, and the cracks started to show. Resources stretched to breaking point. Weight buckling the foundation. Our imagined future, a fading mirage. A broken city. A broken dream. Change needs to come. The city's problems can be solved on the ocean. The environment depends on it. Infrastructure depends on it. Our children's quality of life depends on it. Our journey with the sea is just beginning. It's time for a worldwide awakening on an oceanic scale.
We love technology, we love helping our owners, but there's a reason we do it, and that means we have to do this in a sustainable way to protect our environment and this planet for the future generations. Thank you very much.